In this video, we're going to explore some rotations and some combination solids. The nice thing about this topic is that really we're utilizing the skills that you've developed earlier in the unit, so this isn't really even anything new. Okay, let's go ahead. In example 1, it says they give us this right triangle, and they want us to rotate this particular triangle about line L in order to create a three-dimensional solid. Now, whenever you're rotating a figure about a line, it's very important to pay close attention to exactly which line we're going to rotate around. So I'm going to take my pen here and circle that we're rotating, in this particular example, we're rotating about line L. So if I go to my picture and find line L, this line right here that I just highlighted red is the exact line about which we're turning or rotating our triangle. So if we take and turn the triangle about that line, this blue vertex up here is going to come down here. The purple vertex, because he's already on line L, is going to stay put, and we're going to create or generate this cone-shaped solid. The radius of this cone-shaped solid is the 3 inches. The height of this cone-shaped solid is the 4 inches. So here it says sketch and identify. So again, we've created this cone whose circular base has a radius of 3 inches and whose height is 4 inches. So there's my sketch. As far as the identification, I've already talked about the fact that this figure is a cone. So now that we have this cone, they want us to proceed onwards and find its volume. Well, I know from my formula sheet that the formula for finding the volume of a cone is volume equals 1/3 times pi times the square of the radius times the height. And of course, the first thing I'm going to do is put the formula down on my paper. So volume equals 1/3 times pi times 3 to the second times 4. In this example, they don't specify what exactly I'm supposed to round to, and therefore I'm not going to do any rounding. I'm going to leave my answer as an exact value in terms of pi. But what I am going to do is grab my calculator and multiply the 1/3 times the 3 squared times the 4. Those numbers all multiplied together give me 12 times pi, and then my answer is in cubic inches. So the volume of my cone that I generated by rotating around that line is 12 pi cubic inches. So that's the first type of question that you're going to look at in the topic for today. The second one has to do with volume also, and it says find the volume of the mailbox pictured. So this mailbox is some odd shape that we don't have a formula for on our formula sheet. So what I'm going to do is divide him or split him up into sections for which we can find the volume. So I'm going to split them up so that the top part of that is half of a cylinder and the bottom part of that is a rectangular prism. I can find volumes for both of those figures. Once I know those volumes, I can combine them together in order to determine the volume of the entire mailbox. So I'm going to go ahead and start with the half cylinder. And I can approach this a couple different ways. I can either find the volume of the whole cylinder and then divide it by 2, or I can just start by taking half the volume of a whole cylinder. So I'm going to identify to the person reading my paper that the figure for which I'm finding volume here is this half cylinder. I guess it's helpful if I spell it correctly. And the formula for this is going to be volume equals 1/2 times pi r squared times h. And if I look at this half cylinder, the radius is 4 inches. Its height, the distance between the two bases, is going to be 20. So I'm simply going to plug those numbers into my formula. And similar to the first question, because they don't ask me to round, I'm going to leave my answers as exact answers rather than to multiply them out. So I end up with 160 pi for the volume of that half cylinder. And this is in cubic inches. And now I'm going to go do the same thing for the rectangular prism. And again, I'm going to identify to the reader exactly which piece I'm finding volume for. Volume of a rectangular prism you can either find by doing area of the base times the height, or I'm simply going to do very simple here, length times width times height. So 5 times 8 times 20, or in other words, 800 cubic inches. Now my mailbox is going to be a combination of the two. So I'm going to take the volume of the half cylinder, which is 160 pi, and add to that the volume of the prism, 800. Notice that the cylinder has a pi attached to it. The prism does not. They are not like terms, cannot be combined. So in simplest form, our answer is very simply 160 pi plus 800 cubic inches. As always, I do want you to take a few minutes to think about what you saw and heard in the video, and then summarize your key understandings and your important findings, and see if you can apply your newfound knowledge in order to solve the questions on the next page.